Hey everyone! So today we're going to pull back the curtain on machine learning. We hear all the time about its incredible, world-changing power, but we're going to talk about what happens when it hits a wall. You know, the hidden hurdles that really define its limits out in the real world.
I mean, you hear it everywhere, right? AI and machine learning, they're talked about like these unstoppable, almost magical forces that are solving problems we never even thought were possible. And the hype is absolutely huge.
But, and this is a big but, behind all that amazing potential, there are some very real, very practical limits. So what actually happens when the clean, perfect world of code smacks right into the messy, chaotic real world?
That's what this is all about. We're going to go beyond the hype and take a really clear-eyed look at the boundaries, the challenges that define what machine learning can, and maybe more importantly, what it can't do right now. And look, this isn't about knocking the technology, not at all. Understanding the limits of any tool is actually the most important step to using it smartly and responsibly.
So let's start with the absolute bedrock of any machine learning system, the data. You always hear people say more data is better, but honestly, the truth is a whole lot more complicated than that. You see, ML models are completely 100% dependent on the data we feed them. And yeah, they need huge amounts of it. But the key word here is quality. The data has to be high quality. Which brings us to this classic old-school computer science saying, garbage in, garbage out. It's so simple, but so true. If you have high-quality, balanced, complete data, you're probably going to get a good, reliable result. But if you feed that model junk, unbalanced, incomplete, biased data, you don't just get a bad result. The model can actually learn and then amplify those harmful biases, making things even worse.
This is the perfect way to think about it. The data isn't just one part of the recipe, it's the entire foundation. And if that foundation is cracked and shaky, it doesn't matter how fancy the skyscraper is that you build on top, it's just destined to fail.
Okay, but what if you have perfect data? Well, then you run into another, even stranger problem. Sometimes we have absolutely no idea how the model is making its decisions. This is what's known as the transparency problem.
We call it the black box problem. The model's logic, its inner workings, can be so incredibly complex. We're talking millions of tiny calculations all interacting that it becomes totally unreadable to a human. We can see the data that goes in, and we can see the answer that comes out, but everything that happens in between, it's a total mystery.
So picture this. You put data in, something happens, and a decision comes out. But that middle step, the why, it's just a big question mark. And in a lot of really important situations, not knowing why is just not good enough. I mean, think about how high the stakes are here. If a model denies you a loan, you deserve to know why. If a doctor is using an AI to help diagnose a patient, they need to understand its reasoning. Or if a judge is looking at an AI's recommendation for a prison sentence, we have to be able to explain how we got there. Because the computer said so is not just a lazy answer, it can be a really dangerous one.
So we've got the huge challenge of data quality and this tricky problem of transparency. Now let's talk about what happens when these models finally leave the lab and have to face the messiness of the real world.
And the very first reality check? The cost. Building a serious machine learning model isn't just about writing some clever code. It takes a massive, massive investment of real-world resources. We're talking about a staggering amount of computational power, which means crazy expensive computer hardware. Then there's the financial investment just to develop and scale the thing. And this is the kicker. It is not a one-and-done cost. These systems need constant care and feeding, constant maintenance and monitoring just to keep them working right.
But there's one last challenge, and it's a bit more subtle. The world isn't static, right? It's always changing. But our models, by their very nature, are trained on data from the past. So what happens when the future suddenly stops looking like the past?
At its core, a model is only as good as the patterns it's already seen in its training data. So when completely new, unexpected patterns show up in the real world, the model can become useless really fast. Or even worse, it can become dangerously wrong.
Let me give you a super simple example to make this real. Imagine a big online store. They have a recommendation engine, and it's been trained on months of totally normal, everyday shopping data. And it works great. But then, Black Friday hits, and all of a sudden, people's behavior goes wild. They're buying completely different stuff in weird combinations, and they're in a huge hurry. What do you think happens to that perfectly trained model?
Yep, you guessed it. Its performance just falls off a cliff.
the recommendations it makes are suddenly terrible, because this new reality, this holiday shopping frenzy, looks nothing like the old, calm patterns it was trained on. This is exactly why these models need to be constantly watched and retrained.
So, after all that, what's the big takeaway here?
Well, these problems, the data bottlenecks, the black box issue, the fact that the world keeps changing, they're not reasons to give up on AI. Not at all. They're actually crucial reminders that we need to be smarter about how we build and use it. Really getting a handle on these hurdles is the first step to building AI that isn't just powerful, but is also responsible, fair, and genuinely helpful.
And that kind of leaves us with one last thing to think about. This technology is only going to get more and more powerful. So the real question for all of us is, how do we make sure that as AI gets more powerful, it also gets wiser?